is on conservation of momentum. Conservation simply means keeping things before, first, before, and after. So, what is conservation of momentum? Simple, it's keeping momentum of a system before equal to the sum of momentum even after. So this keeping of momentum is only possible when the system is isolated. These are terms that I think you should familiarize yourself when you're working with this. Isolated. Isolated system means a system on which there is no external forces acting on it, or there is zero external forces acting on it. So the sum of all external forces should be zero for what? For conservation of momentum to be achieved. The other thing that you need to know are external forces. What are external forces exactly that I've been mentioning? External forces are forces outside of a system. There is another new term now, of which is a system. What is a system? System is a set number of objects that interact with each other. So if there are two boxes that are having a collision, they are just a system because it's a number of uh, objects that are interacting with each other. Let me bring up some objects here. Let me say I have this objects, green object, and this green object, and another one. It's green and blue, I think. So if these objects were together first, or let me say they were together, and they were held by a spring together. So the spring was compressed to keep them together like this. So then after the spring is released, the trigger, then these objects they they separate. So the after So I just brought my boxes to the screen. Initially, or should I say before the spring was released, these were together, and after the spring is now triggered. So, or should I call it an explosion? After the spring exploded, now they move their separate ways. So this is after, because there are no external forces act on this system. So this system is said to be isolated. Because the system is isolated, then the momentum is conserved. Then I can state the momentum of this one initially. It was their mass all together times their velocity is now equal to, in this second or the after part, the mass product of mass of velocity of this one plus product and mass of this one is also equal to this one. It's because their momentum was conserved. The practical example that they love to test you with is when a man is using a gun. I'm not too good drawing a gun and shoots a bullet. So first of all, the bullet and the gun are together. Their mass and their mass are summed together, and they have their velocity, of which is how speeding you're holding a gun. So then that is their velocity altogether. Then after you pulled a trigger, an explosion happened, and they move their separate ways like these boxes. Your gun pushes you back, and the bullet runs forward. So that is a separation or explosion. That is also where uh, momentum is conserved. That is the example that I love to test you with. So what is happening in that equation? Their masses first together, then the after part, then after now the mass and velocity of the bullet plus mass and velocity of the gun, but still conserved. But now their masses are just, they have different velocities because they separated. They have their own velocity independently because they are moving independently. There could be another case. Now an object is moving this direction, and it's collide with an object that is moving in this direction. So they are about to collide here in this point. So Firstly, I can say, or after the collision, I mean, yes, before the collision, the mass and velocity of this one was like this, and the mass and velocity was this one. There was sum of their momentum before, and after they collided, they stayed together. So let me say the very same objects after the collision. These are them now. After the collision, they stay together. Because they stay together, the sum of momentum after the collision is going to be their mass all together times their velocity that they have, because they are now attached to each other. There is also a common example that I think I should have started with. There is a case now where the objects come different directions and then they collide and they go their different directions. Simple. This was the object and now this is another object, and they decide to go their different directions. Also, if you're representing that mathematically, it's going to be simple like this. They started the other one was object was on its own, had its own velocity and mass. Then it was added by another one's of both mass and velocity, and after it's going to be the very same thing, because they started separated and after the collision they rebounded. Simple. So there was a collision and they both moved their different parts after. It was just hit and run kind of story. This is exactly my bonus question. Sorry, I have some distraction, so I had to get this like this. This bonus question now, what if now someone is falling, or maybe an object? This object, this one was moving this way, is moving this way, and now an object is dropped on a moving object. Let me say a car is passing under a bridge and you decide to draw a bag of something on it. So what is happening, or how could I explain that or evaluate that using conversation of momentum? Specifically, I said it's total linear momentum, conversation of total linear momentum. So because of these are on y-axis, and this the object is dropped and it has a velocity. Its velocity is on y's. Oh, sorry. Its velocity is on y's and this one's velocity is on x's. This is not linear now because it now consists of two dimensions, the x and the y's. This is the x here and the y's there. So this is now a two-dimension thing. So this is linear, it goes only this way. So because this velocity is on the y-axis initially, so it is considered zero velocity because here we are looking at it at x-axis. First of all, it's more of like any other momentum problems. Initially you have your mass because this one is coming on its own and it's dropped at its own velocity, and it meets an object that is also in motion. It has its mass and it has its own velocity, and after now it's going to have the very same now they're going to be together, have the very same mass add up together and the very same velocity. But the difference is, for initial velocity of this object, of which is this v here, it has to be 0. Why 0? Because it is on y-axis. It is considered as not moving on the x-axis. So this one will substitute the velocity and to be 0, and it's going to plus mv of the bottom one, of the green one, and the after again it's going to be the m's all together. They are added, or sum of masses times the velocity. And because of this velocity, or because it was dropped coming with velocity of y-axis, it is 0. So exactly, it is not moving. So it's going to make what? It's going to make mv of this object to be the only momentum included to equal to the mass of both of them. Mass of both of them times product. And this was it. So thank you for watching. Please subscribe, comment and hit the bell button so that you'll be updated if any comment on any content that we upload. Thank you.